Asteroids CE2XZW2, fake or truth? January 2026. The news breaks with a frightening headline. An asteroid is heading toward Earth. The titles get harsher and harsher. Dangerous close approach. Possible collision. The countdown has begun. Social media explodes. People share alarming posts, remember apocalypse movies, and start asking the same question. Is this real, or are we being scared again? The name sounds like a secret code to view. Yesterday nobody had heard of it, today everyone is talking about it. Let's start with the basics. The asteroid does exist. It was genuinely detected by telescopes. This is not a fake name or a blogger's invention, but this is where the important part begins. The object was discovered very recently, which means its orbit was calculated using a very small amount of data. At this stage, trajectories can look terrifying. Lines intersect, distances shrink, algorithms produce alarming scenarios. This is exactly how loud, scary headlines are born. The size of CE2XZW2 is estimated at about 20 meters. Sounds dangerous, right? But let's compare. In 2013, a meteor of a similar size exploded over Chelyabinsk. It never hit the ground, but the shockwave shattered windows and scared thousands of people. That object wasn't detected until after the explosion, and even that event was not a global catastrophe. There are many similar cases. In 2004, the whole world was talking about asteroid Apophis. The media claimed a high probability of impact and a threat to Earth. Risk percentages were discussed on television. We all know how it ended. After orbit refinements, the danger disappeared. Apophis flew past Earth and became a textbook example of how astronomy really works. These stories repeat regularly. Every year, NASA and other agencies detect dozens of near-Earth objects. Some of them initially appear on risk lists, only to disappear completely days or weeks later. The reason is simple: new observations change the calculations. The same thing is happening with CE2XZW2. Early data suggested an extremely close approach. Media outlets grabbed the scariest numbers and presented them as almost guaranteed facts, but neither NASA nor the European Space Agency issued any alerts. There are no official warnings and no confirmed impact scenarios. Moreover, there is a possibility that in the information cast, CE2XZW2 was partially confused with another object, Three-Eyed Atlas. This object is also being discussed, but unlike the frightening headlines, Three-Eyed Atlas is currently moving away from Earth and poses no threat because of similar wording, incomplete data, and rushed publications. Different objects may have been merged into one scary story, amplifying the panic. It's important to understand this. If a real threat existed, the information would immediately appear in international asteroid monitoring systems. That did not happen, which means this is not a doomsday asteroid, but a classic example of how early, raw data turns into sensational news. But here's the real truth: Earth is not isolated. Space is close. Asteroids pass near our planet all the time, sometimes closer than the moon, sometimes closer than satellite orbits, and almost always without consequences. CE2XZW2 is not a fake, but it's also not the end of the world. It's another space story where science says we need more data, while the internet screams we're doomed. Fake or truth? Now you decide. Space reminds us of its unpredictability with frightening suddenness. Just a day after its discovery, the asteroid designated with the dry code CE2XZW2 has transformed from another entry in the catalog into an object of intense focus and concern for planetary defenders worldwide. According to the latest statements from scientists, the probability of its collision with Earth is assessed as significant. The nominal orbit is 3,000 kilometers from the Earth's center. This means it will collide, but one must understand that this is a probability of collision, albeit a high one, notes Nikolay Zheleznov, a senior researcher at the Institute of Applied Astronomy of the Russian Academy of Sciences. This uncertainty permeates every aspect of the situation. The most alarming question is the timeframe. There is a catastrophic lack of data to accurately determine the timing of a potential impact. The day X scenario could, in theory, unfold in the coming hours or days, presenting humanity with unprecedented challenges in modern history for rapid response. However, scientists are quick to reassure. As new observations are obtained, the orbit will be refined, and the Earth may simply move out of the calculated risk ellipse. The size of the object is estimated to be approximately 20 meters in diameter, making it a close relative of the Chelyabinsk meteor of 2013. And here lies the key factor. Bodies of such mass have almost no chance of reaching the planet's surface intact. They disintegrate and vaporize in the dense layers of the atmosphere, releasing colossal energy in the form of a powerful airburst. Thus, Even in the worst-case scenario, we would face not an apocalyptic impact leaving a multi-kilometer crater, but a serious regional event. The primary damage would be caused by the shock wave, capable of shattering windows and damaging buildings over a vast area, as happened over Chelyabinsk. The very detection of the object such a short time before a potential close approach is both a warning sign and a demonstration of progress. The Chelyabinsk meteor went unnoticed, approaching from the direction of the sun. The 2008 case, when asteroid 2008 TC3 was detected 19 hours before its impact in Sudan, was the first success in history. Now, in 2026, we see that monitoring systems, though imperfect, are working. They are detecting threats, albeit with an extremely small margin of time. At this moment, the world is watching a unique cosmic drama unfold in real time. Astronomers across the planet, from Hawaii to the Caucasus, are pointing their telescopes at this faint moving point. With every hour, with every new calculation, the picture will become clearer. The outcome can be anything, from the Earth completely moving out of the danger zone to the necessity of preparing for an event that will likely enter the history books. The most important thing now is not to succumb to panic, but also not to ignore the facts. This is a moment when science, technology, and global cooperation are undergoing a severe stress test. All eyes are on the sky and on the updating data on the screens in control centers. In recent years, humanity has been looking at the sky more and more often, not only with admiration, but also with concern. Space no longer seems distant and completely safe. Asteroids, fireballs, and unknown objects are increasingly appearing in the news and provoking heated discussions. Today we will talk about 3 mysterious objects of 2025, 2025 for 5, 2025 SC79, and 2025 S6. Each of them is unusual in its own way, and makes us think about how well we actually control the situation in near Earth space. Let us begin with asteroid 2025 for 5. It was discovered by astronomers at the Vera Rubin Observatory in Chile. This is one of the most advanced observatories in the world, designed for systematic sky surveys and the detection of new cosmic objects. According to specialists, the asteroid's diameter is about 710 meters. To understand the scale, this is comparable to the size of a large stadium or a small urban district. A collision of such an object with Earth would have catastrophic consequences for an entire region. However, the main feature that makes 2025 for 5 stand out is its record-breaking rotation speed. The asteroid completes one full rotation around its axis in about 113 seconds. That is, in less than 2 minutes. For an object of this size, this is extremely unusual. Large asteroids usually rotate much more slowly, because a high rotation speed can cause them to break apart under centrifugal forces. In fact, if an object spins too fast, it risks literally tearing itself apart. Scientists suggest that such a high speed may indicate a special internal structure. Possibly, the asteroid is a very dense monolithic body rather than a loose pile of rubble, as many other asteroids are. It is also possible that in the past it experienced a collision with another body that spun it up to such speeds. Observations like these help astronomers better understand the evolution of small bodies in the solar system and refine models of their behavior. Now let us move on to the second object, asteroid 2025 SC79. It was detected in September 2025. For a long time it remained invisible because sunlight interfered with the detection of any objects in that region of the sky. This is a common problem in astronomy. If an asteroid is located against the bright background of the sun, telescopes simply cannot register it. The size of 2025 SC79 is estimated at about 700 meters, making it one of the largest objects whose orbit passes close to Earth. Such bodies are classified as potentially hazardous asteroids. This does not mean that a collision is inevitable, but these objects require constant monitoring and precise refinement of their orbits. The peculiarity of this asteroid is that it was discovered relatively late, when it had already approached the observable zone. This once again raises the issue of so-called blind spots in the space monitoring system. Despite technological progress, humanity still cannot see a significant part of near-Earth space, especially in the direction of the sun. Theoretically, an object could appear from that direction and be noticed too late for any effective response. Nevertheless, according to preliminary data, 2025 SC79 does not pose an immediate threat in the near future. Its orbit is being carefully studied, and astronomers continue to refine its trajectory in order to rule out possible risks. The most mysterious story is connected with the object 2025 S6. Initially, information about it appeared in open NASA databases. It was reported that on the night of October 27, 2025, a bright green fireball was observed in the sky over central Russia. This phenomenon attracted the attention of both professional astronomers and ordinary witnesses. It was assumed that on October 28 an asteroid about 2 meters in size would pass at a distance of approximately 150,000 kilometers from Earth by cosmic standards. This is quite close, although still considered safe. However, soon afterward the data about this object were removed from public databases. This triggered a wave of rumors and speculation in astronomical communities. A version appeared suggesting that under the designation 2025-6 there might have been not a natural asteroid, but an artificial object, namely the Chinese satellite Drobie. If this is true, then the bright fireball could have been related to fragments entering the atmosphere or to specific features of the satellite's trajectory. Such confusion demonstrates how difficult it can sometimes be to distinguish natural celestial bodies from man-made objects. Thousands of satellites, rocket stages, and fragments of space debris are already orbiting Earth. Their trajectories may occasionally coincide with asteroid observation pods, leading to misclassification. This once again highlights the importance of data transparency and international cooperation in the field of space monitoring. If we look at all three stories together, a common trend becomes clear. Space is becoming increasingly crowded with objects that need to be tracked. On the one hand, modern telescopes allow us to detect even relatively small bodies at enormous distances. On the other hand, there are still regions where observations are difficult, and information can be incomplete or contradictory. The fast-spinning giant 2025-5 reminds us how diverse asteroids can be in their physical properties. The large and long-hidden 2025 SC79 points to vulnerabilities in early detection systems, and the mysterious 2025 S6 shows how easily rumors and alternative theories arise when data disappear or change. All these cases raise an important question: are we ready for a real threat from space? So far, no direct danger from these objects has been confirmed, but the very possibility of a sudden appearance of a large asteroid pushes scientists to develop planetary defense systems. Research is being conducted on methods of changing asteroid trajectories. Possible impact scenarios are being modeled, and international data-sharing programs are being created. For an ordinary person, such news may seem distant and abstract, yet it is precisely these observations that shape our understanding of the universe and help us prepare in advance for potential risks. Space remains unpredictable, and every new discovery is another step toward understanding it better and protecting our planet. Perhaps in the coming years we will witness new discoveries, even more unusual objects, and new technologies that will allow humanity to feel more confident under the open sky. Until then, all that remains is to follow the news closely, ask questions, and remember, even a tiny point in the sky can have enormous significance for the entire Earth.
The sun has just delivered a blow that is forcing scientists to rethink everything they thought they understood about space weather. What we are witnessing right now is not just another solar flare. Astronomers are already calling it the storm of a generation, an event so powerful that it has shattered records that stood unbroken for more than 20 years. For nearly 2 decades, the sun appeared relatively restrained. Solar cycles came and went, but truly extreme events were absent. Many experts quietly assumed that the most violent outbursts belonged to the past, to history books and archived datasets. That assumption has now been destroyed. This eruption did not merely approach previous records, it surpassed them. To understand the scale, we need to look back. In October and November of 2003, the sun unleashed a series of massive eruptions known as the Halloween storms. At their peak, instruments recorded an X17.2 class solar flare, so powerful that it overwhelmed some sensors. For years, this event stood as the benchmark for extreme solar activity in the modern era. What has just occurred exceeds that benchmark. Scientists monitoring real-time data confirmed it with disbelief. The numbers climbed beyond expectations, beyond models, beyond what many believed was realistically possible in the current solar cycle. A new record has been reached, the strongest solar flare of the 21st century. But the flare itself is only the opening act. The true danger lies in what followed. A massive radiation storm, also known as a proton storm. This is a flood of high-energy particles accelerated to near relativistic speeds and hurled directly into interplanetary space. When these particles reach Earth, they interact with satellites, astronauts, aircraft, and the planet's magnetic shield. On the official 5-level radiation scale, the S scale, this event has been classified as S for severe. To grasp how rare that is, consider this. The last S for radiation storm was recorded in 2005, almost 20 years ago. The highest category, S5 extreme, has never once been officially recorded in the history of the space age. Humanity is now operating one step below the absolute theoretical maximum. This alone makes the event historic. The closest parallel once again comes from 2003. During the Halloween storms, the radiation level reached S3, classified as strong. Even then, the consequences were serious. A major NASA scientific satellite was permanently disabled. High-frequency radio communications failed across large regions. Aircraft were forced to reroute. Maritime navigation systems experienced outages. Auroras were seen far beyond their usual latitudes, reaching as far south as the Mediterranean. What we are dealing with today is significantly more powerful. Within minutes of the eruption, alerts were issued across the global space weather monitoring network. Satellite operators began emergency procedures, placing spacecraft into safe mode. Non-essential systems were shut down. Sensitive electronics were powered off. Every precaution was taken to prevent irreversible damage. Satellites are particularly vulnerable to radiation storms. High-energy protons can penetrate shielding, flip bits in memory systems, permanently degrade solar panels, and cause sudden system failures. In extreme cases, satellites can be lost entirely, silent, dead objects drifting in orbit. Modern civilization depends on these machines more than most people realize. Satellites handle GPS navigation, financial time synchronization, weather forecasting, internet backbones, television broadcasting, military surveillance, and disaster response. A failure in space does not stay in space, it cascades downward. Astronauts face an even more direct threat. On board the International Space Station, radiation levels are closely monitored. During severe storms, crews are instructed to move into the most shielded areas of the station, where water tanks and equipment provide additional protection. Outside Earth's magnetic field, such as on the Moon or during deep space missions, this level of radiation would be potentially lethal. This storm is a stark warning for humanity's future beyond Earth. Plans for lunar bases, long-term space stations, and missions to Mars all assume periods of relative solar calm. Events like this expose just how fragile those assumptions may be. Meanwhile, Earth itself is not immune. As the charged particles reach our planet, they collide with the magnetosphere, compressing it, distorting it, and injecting enormous amounts of energy into the system. This triggers a geomagnetic storm, forecast to reach E4, severe, the second highest category on the geomagnetic scale. For comparison, the infamous March 1989 geomagnetic storm, the one that caused a 9-hour blackout across Quebec, Canada, was also a G4 event. That storm damaged transformers, disrupted radio communications, and forced emergency responses across North America. Geomagnetic storms induce powerful electric currents in long conductive structures. Power lines, pipelines, railway systems, undersea cables all can act as antennas for geomagnetically induced currents. Transformers can overheat. Protective systems can trip. Voltage instability can spread across entire regions. Power grid operators in high-latitude regions are on high alert. Scandinavia, Canada, northern Russia, and the northern United States are particularly vulnerable. Controlled outages may be implemented to prevent catastrophic damage. The goal is not convenience, it is survival of the infrastructure itself. A destroyed transformer is not easily replaced. Some take months, even years, to manufacture. A widespread failure would not be a temporary inconvenience, it would be a long-term crisis. Communication systems are also at risk. High-frequency radio waves, used by aviation, shipping, and emergency services, can be completely disrupted during severe space weather. GPS and GLONASS signals may become inaccurate or unavailable. Aircraft flying polar routes may be forced to divert, increasing fuel costs and flight times. Maritime navigation may revert to older, less precise methods. And then there is the sky. As the storm intensifies, Earth's upper atmosphere begins to glow. Charged particles collide with oxygen and nitrogen atoms, causing them to emit light. Curtains of green, red, and violet ripple across the heavens. These auroras are not merely beautiful. They are visible proof of a planetary-scale energy transfer. During events of this magnitude, auroras can appear far from the poles. Cities that have never seen them before may suddenly find the night sky alive with color. Moscow, St. Petersburg, Central Europe, the northern United States, possibly even farther south. For many, it will be the most spectacular natural display of their lives. For scientists, it is a goldmine of data. Instruments across the world are recording every second. Particle flux, magnetic field distortions, ionospheric density changes. This information may redefine models of solar behavior and help answer a crucial question, now dominating the discussion. Is this the peak or only the beginning? History offers a sobering clue. Extreme solar events often arrive in clusters. The 2003 Halloween storms were not a single eruption, but a sequence of powerful flares and coronal mass ejections over several days. If this pattern repeats, Earth may face additional impacts in the near future. And beyond recorded history lies an even darker reminder. In 1859, the Carrington event struck Earth with such intensity that telegraph systems caught fire. Operators were shocked, and auroras were seen near the equator. If a storm of that magnitude occurred today, the consequences would be unlike anything humanity has ever experienced. This is not an apocalypse, but it is a stress test for our technology, our infrastructure, and our assumptions. Over the past 20 years, civilization has become exponentially more dependent on space-based systems, all while the sun remained deceptively quiet. That quiet is over. We live inside the atmosphere of a star capable of releasing, in minutes, more energy than humanity has produced in its entire existence. Today, it has reminded us of that reality. We are watching, we are measuring, we are hoping, and we now know, without any doubt, that this will not be the last time the sun reminds us who is truly in control.
Space continues to be a source of astonishing discoveries for humanity, with each new event capable of reshaping our understanding of the universe. Just recently, the world was gripped by alarming news of a mysterious object that suddenly appeared on astronomers' radars, registered under the dry technical designations CE2XZW2. Preliminary calculations by scientists indicated an incredibly close approach of this object to Earth, with some models even suggesting a probability of direct impact. Researcher Nikolai Zheleznov from the Institute of Applied Astronomy of the Russian Academy of Sciences presented data, suggesting the celestial wonder was about 20 meters in diameter, comparable to the height of a modern, 7-storied building. His forecasts sounded ominous. The orbital trajectory of CE2XZW passed a mere 3,000 kilometers from our planet's center, which formally meant a potential intersection with Earth's atmosphere. Were this to happen, the object likely would not have reached the surface intact but would have exploded in the dense, atmospheric layers, creating a bright flash and possibly leaving behind only a trail of small fragments, to fall somewhere across the planet's vast, sparsely populated expanses. However, as soon as this data became public, skeptical voices arose within the scientific community. Specialists from the Solar Astronomy Laboratory at the Space Research Institute of the Russian Academy of Sciences officially stated that information about an inevitable asteroid impact was unreliable and lacked sufficient observational evidence, and this skepticism proved to be justified in the most remarkable way. Soon, an official clarification followed from the most authoritative institution in such matters, the Minor Planet Center of the International Astronomical Union. The center specialists conducted a thorough analysis of the trajectory and characteristics of the mysterious CE2XZW2 and came to a sensational conclusion. This object was never a new asteroid threatening Earth. It turned out that a rare identification error had occurred in the observation data. What tracking systems had mistaken for an unknown near-Earth asteroid was, in fact, an already discovered and catalogued interstellar comet named 3I Atlas. This comet is a rare and extremely interesting visitor to our solar system, as it arrived from the depths of interstellar space. From beyond the gravitational influence of our Sun, it had already passed its point of closest approach to Earth and was now calmly moving away from our planet, posing absolutely no danger. But while the threat of collision was safely averted, the most fascinating part of this interstellar traveler's story was just beginning. Scientists worldwide are eagerly awaiting January 22nd, when a rare and incredibly valuable astronomical event for science will occur. On this day, Earth will occupy a special position in space, finding itself almost in a straight line between the Sun and comet 3I Atlas. This configuration, where a celestial body is positioned almost directly opposite the Sun from an Earth observer's perspective, is called opposition, And for comets, this is an especially significant moment. In this alignment, the comet becomes maximally illuminated by sunlight, causing a sharp increase in its apparent brightness. For astronomers, this outburst is not just a beautiful sight but a priceless scientific gift. The intense illumination allows for detailed study of the composition of the coma, the gas and dust envelope around the comet's nucleus, and analysis of the structure of its tail, which stretches for millions of kilometers under the pressure of the solar wind. Since 3I, Atlas is an interstellar object, analyzing its substance will give humanity its first opportunity to directly, albeit remotely, study material formed in another star system. This will allow for conclusions about the composition of protoplanetary disks around other stars and, perhaps, an understanding of how unique or, conversely, typical the conditions that led to the formation of our own solar system are. Interestingly, this same day, January 22nd, will delight observers with another beautiful phenomenon. A close parade of inner planets, Mercury, Venus, and Mars will converge in a very narrow sector of the sky, forming a compact and bright triangle, which in itself will become a wonderful target for observation and photography. But for science, the main event of January will undoubtedly remain the visitor comet. Following this unique moment, Comet 3I, Atlas will continue its solitary journey through our planetary system. Its trajectory now leads toward the outer planets. As early as March 16th of this year, it will pass at a distance of approximately 53.6 million kilometers from the giant Jupiter. The gravity of the king of planets will undoubtedly adjust the path of the interstellar guest, after which it will forever leave the confines of the solar system, and once again dissolve into the dark, cold interstellar space, carrying its secrets away and leaving terrestrial scientists with terabytes of priceless data. 4 years of research. Thus, a story that began with a false alarm about a potential apocalypse transformed into a narrative of extraordinary scientific fortune. It vividly demonstrates how modern astronomy, built on international collaboration and cross-verification of data, is capable not only of preventing panic but also of using any signal, even an erroneous one, to look deeper into the mysteries of the cosmos. Once again, space has taught us a lesson. Often behind an apparent threat lies a rare opportunity for knowledge. Our task is to remain vigilant, curious, and open to the wonders that arrive from the depths of the universe.